So when dealing with simplifying radicals, which is just the mathematical term for a square root in this case, there is a pattern here that hopefully we can figure out when we look at a few of these examples. So if you take the square root of 2 times the square root of 2, anything times itself is just that value squared. So 2 times 2 would really be 2 squared. Well, 2 squared is 4, and the square root of 4 equals 2. 3 times 3 is 3 squared. The square root of 3 squared equals 3. 3 squared is 9. The square root of 9 is 3. So what happens when you're simplifying roots? What we're really looking for is a perfect square or a pair, meaning the same thing, of the same value. So if we go over and look at the examples, square root of 5 times the square root of 5, you could write that as the square root of 5 squared or the square root of 25, but both of them would equal just 5. 15 times 15 equals 15. Square root of 20 times the square root of 20 equals 20. So anytime you guys have a pair of something, underneath that square root, two things multiplied together, those items squared under the square root just cancel each other out and leave you, that should be 11, not 2, with the value underneath of the root. So let's do some examples together. So finding the exact answer is important in real world problems. Thus, we often want to find the simplified radical form instead of a decimal approximation. So this means that it's simplified if there are no more perfect square roots inside that radical. So when we do the square root of 18, we can do this two ways. We could say the square root of 18 is 9 times 2, and say the square root of 9 is just 3. Or we can factor it out and find those pairs of the same number. We want the same number. So if we were to factor 18, it doesn't matter if you start with 9 and 2 or 6 and 3. We're just not starting with the number itself and 1. We cancel out anything that we factored, but that pair is what represents the perfect square. And that one pair, even though there's 2 3s, it's just a single pair. So the pair is what comes out, and what's left by itself without a matching value or a pair is what stays underneath. So pairs out. What's left goes underneath. So let's look at 80. So I would probably do 10 and 8. 5 and 2, 4 and 2, 2 and 2. So again, anything we sort of factored, we can cancel out. We're only looking at the prime numbers at the end of the branches. So what do we have a pair of? And we're finding all the pairs because those represent perfect squares. So a pair, and this 5 is left. So each pair comes outside. The number left stays underneath. So 2 times 2 is 4 outside square root 5. So 3 times the square root of 98. So 98 could be 49 and 2. 49, 7, and 7. So this is a pair, and this is what's left without. So that pair is outside. The square root of 2 is left, but you had a 3 out front here already. So that just needs to come over with the 7. So just don't forget to check if you have something out in the front already of your radical. It needs to continue with your problem in your final answer. So this will become 21 square root 2. Pairs represent perfect squares and they go outside. Values left by themselves stay underneath the radical.